Alright, so let's talk about what the Fibonacci sequence is. The Fibonacci sequence is found by taking a number and then adding the number before it to it. So we start with 1. Now, there is no number before 1, so we're just going to add 1 to 1, and that's going to give us 2. Now we're going to take 1, which was the previous number, and we're going to add it to 2, which was the number we found when we added 1 to 1, and then that's going to give us 3. Now we're going to do the same thing over, and we're going to do 3 plus 2 equals 5, and then we're going to do 5 plus 3 equals 8, and then we're going to get 13, and then 21, and then 34, and then this is going to go on and on and on to infinity. The sequence itself is named after Italian mathematician Leonardo Fibonacci, who published the formula in his book Liber Abaci in 1202. However, the sequence has been used since the dawn of civilization. It's been found in early Indian mathematical texts, and it was also used by the Greeks in their architecture. What's so cool about the Fibonacci sequence is that it appears naturally in many forms of nature. How this translates to the markets is that markets are random, but they're also natural, and so you're going to see the sequence appear in them quite a lot. So let's find out more about the formula. The formula is f of n equals f of n minus 1 plus f of n minus 2. And as this number grows and grows and goes towards infinity, the ratio of growth between the numbers is going to be 1.618%. And we call this the golden ratio. Now that's great and all, but let me show you how the golden ratio appears in nature. Here we have a grid, and you can see that we have 1, and then 1, and then 2, 3, 5, and 8. And this would keep on going on to infinity. But if we draw a spiral going outwards from the innermost grid, you can see that it has a certain distinctive shape. Now, where have you seen that spiral before? Most easily, you've probably seen it in a nautilus shell or a conch shell. Here you can see that the spiral has the same exact pattern as the Fibonacci sequence. Also, we see it in nature as well, too. Look at this hurricane. The shape of the hurricane almost 100% resembles the growth rate of the Fibonacci sequence. We're also going to see it in flowers. So you can see here that as the flower spirals outward, it's going to grow at the Fibonacci growth rate, or the golden ratio, 1.618. Here's another plant that grows at the golden ratio. Also, we're going to see the golden ratio in architecture and in many man-made structures. And the reason for this is that the golden ratio has certain aesthetically pleasing characteristics which the human brain likes. Now, while the Parthenon was built many centuries back, before Fibonacci had actually codified his formula in his mathematical text, you can see that Grecian architects used the golden ratio in their building of the Parthenon. We even use it today. This building uses the Fibonacci spiral to act as the curve for its roof. The golden ratio is known as the growth rate, and this is going to be important when we are dealing with the markets, because the markets grow and decline at certain rates, and they're going to grow at certain ratios. And we can use these ratios when we're trying to predict our entry points and our exit points in our day-to-day trading. So let's go on to the next video, where I'm going to go over the different Fibonacci levels and how you can use them with trading.